Welcome to the DIY Honda Garage channel. This presentation addresses Diagnostic Trouble Code DTC P24B8, which indicates an issue with the Evaporative Emission Leak Check Module, ELCM, pressure sensor in the 2023 Honda CR-V. The purpose of the ELCM pressure sensor is to monitor pressure levels within the vehicle's evaporative emission control system, ensuring that fuel vapors are contained and managed efficiently. When the sensor's output voltage strays beyond specified parameters, the Powertrain Control Module, PCM, registers an abnormal condition and stores this DTC. The goal of this guide is to provide a step-by-step troubleshooting process for resolving the P24B8 error, identifying potential causes, and determining necessary repairs. DTC P24B8 is related to the Evaporative Emission Control System, specifically involving the ELCM pressure sensor. This sensor plays a critical role in measuring pressure changes within the evaporative emission system, allowing for the detection of potential leaks and ensuring compliance with emission regulations. It is typically integrated within the ELCM, which is strategically located near the fuel tank, to monitor vapor levels effectively. A malfunction in the ELCM pressure sensor may lead to the PCN detecting an abnormal condition, triggering the storage of the DTC P24B8. Proper operation of this sensor is essential for the overall functionality of the emission system. When diagnosing DTC P24B8, several potential causes must be considered. Firstly, a faulty ELCM pressure sensor could be the main culprit, as this component could produce out-of-range signals. Circuit issues, such as open wires or shorts, can also affect the sensor's output and mislead the PCM. Additionally, problems with the Powertrain Control Module, PCM, itself may contribute to the error, especially if other related components have been verified as functional. It's important to systematically evaluate each of these potential causes to identify the root of the issue. Symptoms arising from DTC P24B8 can vary, but they typically include the illumination of the check engine light, CEL, on the dashboard, which serves as a notification to the driver of an underlying issue. The EVAP system may also demonstrate performance issues, such as failing to maintain appropriate pressure levels, which can lead to fuel vapors escaping and contributes to environmental concerns. Additionally, drivers might notice abnormal fuel consumption, as an inefficient emission system can lead to increased gasoline usage. Identifying these symptoms early is essential to maintain vehicle performance and compliance with emission standards. In this first troubleshooting step, begin by turning the vehicle's ignition to the on position, which is a critical precondition for testing. Utilize the Honda Diagnostic System, HDS, to access the absolute pressure readings from the ELCM pressure sensor. According to diagnostic data, if the HDS reports a value that is either below 331 millimeters per liter or above 897 millimeters per liter, you will have successfully duplicated the detected failure condition. This step is crucial as it sets the groundwork for further inspections and helps confirm whether the issue is indeed with the ELCM pressure sensor or related components. For this second step, maintain a focus on the EVAP leak check module by ensuring the connector 8P is disconnected for accurate testing. Begin measuring the output voltage from the sensor while the ignition is in the on position. The normal condition for the voltage should be approximately 5.0 volts. If this value deviates significantly, it can indicate that the ELCM pressure sensor is faulty or that there are issues within the circuit itself. Documenting these measurements helps determine the next course of action and ensures an accurate diagnosis for the DTC. In this third troubleshooting step, start by jumping the connectors of the ELCM pressure module terminal number 7 and terminal number 8. This action simulates a standard operational scenario for the sensor. Following this, turn the vehicle to the on mode again, and once more check the absolute pressure reading through the HDS. The expected normal condition in this situation is a reading below 897 millimeters mercury. If the readings are as expected, it suggests the module is likely malfunctioning. However, if values are abnormal, the issue may lie within other associated components, necessitating further evaluation to pinpoint the exact problem. The fourth step in the troubleshooting process focuses on inspecting the wiring associated with the EVAP leak check module. Begin this step by verifying the integrity of VCC6 and SG6 circuits to rule out any open wire issues. With both the EVAP leak check module connector 8P and PCM connector E 80P disconnected, perform an inspection in IG mode. The normal condition here should present continuity, confirming there is less than 1 ohm of resistance. If any abnormalities are noted during this inspection, it indicates issues in the circuit that must be addressed to rectify the DTC P24B8 error. In the fifth troubleshooting step, the focus shifts to the ELCMPA wiring. This involves ensuring that the module's circuitry is intact and that there are no shorts to ground. Start by disconnecting the EVAP leak check module connector 8P and PCM connector A 50P to facilitate the inspection. Much like in previous steps, perform an open wire inspection in IG mode, confirming that there is continuity without any abnormalities, specifically checking for less than 1 ohm of resistance. Also, make sure that any potential shorts are accounted for by confirming a resistance of more than 1 megaohm. Identifying issues at this stage is essential for revealing paths leading to the DTC P24B8. The final troubleshooting step is to inspect the Powertrain Control Module, PCM. This module is vital as it interprets signals from various sensors and components controlling critical engine functions. If all previous inspection items indicate normal conditions and the DTC P24B8 is still present, this strongly suggests that the PCM itself may be the source of the problem. Testing the PCM often involves complex diagnostic routines, but confirming its status is essential for resolving the DTC efficiently. After thorough assessments, if the PCM is determined to be faulty, a replacement or reprogramming may be necessary. Upon completing all necessary repairs associated with DTC P24B8, it is crucial to verify that the issues have been resolved. Begin this process by rechecking the entire system, ensuring all components function correctly. After confirming repairs, use the Honda Diagnostic System, HDS, to clear any DTCs stored in the vehicle's onboard computer. This step is vital so that the system can recalibrate and operate optimally. Finally, it's important to scan the vehicle's systems again to ensure no additional error codes are present, which would indicate whether the repairs have been successful or if further diagnosis is required. Preventive maintenance plays a significant role in mitigating issues such as DTC P24B8 in the future. Regular inspections of the EVAP system can help identify potential problems before they escalate. It's beneficial to monitor the performance of the emission system periodically, looking for signs such as unusual fuel consumption or emissions-related warning lights. Proactive troubleshooting and addressing any warning indicators promptly can prevent more serious and costly repairs down the line, helping to maintain the integrity of the vehicle's emission systems. By fostering an awareness of these practices, vehicle owners can contribute to a healthier environment and ensure their Honda CR-V continues to operate efficiently. In conclusion, DTC P24B8 identifies a serious issue with the ELCM pressure sensor within the Honda CR-V's Evaporative Emission control system. Understanding the potential causes, such as a faulty sensor, circuit issues, or PCM problems, is vital for effective troubleshooting. Following the structured step-by-step process outlined in this guide can help diagnose and resolve the issue efficiently. Furthermore, implementing preventive maintenance strategies can be beneficial in avoiding similar complications in the future. By being proactive, owners can ensure their vehicle remains up to standard with emission controls while also enjoying optimal performance levels. Please like and subscribe to the channel. See you next time.